quite a number of problems, a variety of problems, and each problem had a unique set of roots for the characteristic equation. Yeah, so the first equation we looked at was the third differential coefficient of y with respect to x minus the second differential coefficient of y with respect to x minus 12, then dy over dx is equal to 0. So we worked it out and arrived at the general solution, which gave us y equals c1 plus c2 e to the 4x plus c3 e to the minus 3x. That was the first question. Then the second question was the second differential coefficient of y with respect to x plus 6 dy over dx plus 9y is equal to 0. Yeah, so this one, the procedure, we first converted to the D notation. From the D notation, we went to the characteristic equation, got the roots, and wrote down the general solution. Number 3 was the third differential coefficient of y with respect to x minus 2, the second differential coefficient of y with respect to x minus 4, dy over dx plus 8y is equal to 0. So the solution, step 1, we converted the given differential equation into the D notation. From there, we came up with the auxiliary equation, from which we got 3 roots. And the 3 roots led us to having a general solution of y equals c1 e to x plus c2x e to the power 2x plus c3 e raised to the power negative 2. So for this general solution, we stated that 2 of the solutions are equal. 2 of the solutions are equal. Let's put the pointer. 2 of the solutions are equal, which are M1 is equal to 2 and M2 is equal to 2. So therefore, part of the general solution recognizes the fact that 2 of the roots are equal, hence having an x appearing on the second term there. Okay, then we went to the fourth one. We have a different notation here. We're given a question in D notation. They've already converted for us. So all we needed to do was to come up with an auxiliary equation. Then the roots of the equation, the ones we call the characteristic roots. And for this particular question, we got 3 equal roots. 3 equal roots. So then the general solution gave us y equals c1 e to the power x plus c2 x e to the power x plus c3 x squared e to the power x. Then we went on to, we moved to the 5th question. It was also already in the D notation. So in the solution, we came up with the auxiliary equation. Now this auxiliary equation, after studying it, it was found that it did not have real roots. It didn't have real roots. I think it gave some bit of problems working out if you had to find factors. I don't know what method you can use if you have to get factors. Otherwise, this will have you get stuck somewhere. So the m squared minus 2m plus 10 equals 0 is the auxiliary equation. And after studying this, we found that it could not be solved using the usual means. So instead, we demonstrated the use of the quadratic formula. So I was just putting in this information which we yesterday had explained. Okay, so then from we've seen from the quadratic formula, the roots are giving us 1 plus or minus 3i. So let's move on to this other side. You see, so M1 is equal to, for the positive valued complex number, we have 2 plus 6i over 2. So the 2 will divide both sides of the plus sign. So 2 into 2 is 1, 2 into 6 is 3, then the I. So where the I think we illustrated yesterday, the I is the square root of -1. Yeah, so I is equal to under the root -1. So in electrical engineering, we use the letter J. Or in circuit analysis, since every one of you does circuit analysis, yeah, we expect that you should have come across a J in electrical principles. Okay. Then the general solution, we have C1e to that power, then to the complex power multiplied by x plus C2e to the complex power multiplied by x. Have you seen that the two powers are conjugates of each other? So 1 plus 3i is the conjugate of 1 minus 3i. So then the final general solution gives us y equals C1e raised to the power x cos 3x plus 2 plus C2, sorry, e to the power x sine 3x. Okay. Then we went on to solving the sixth question, which was also in the D notation. So we had to convert it to the auxiliary equation. And from the auxiliary equation, we came up with the 2 complex numbers and 1 real number. So we have 2 complex numbers as solutions. So we follow the procedure for getting the general solution given unreal solutions for the characteristic equation. We have C1e raised to the power 0x. The 0 here is this 0, the root on the extreme left. That's the 0x plus C2e raised to the power, the complex number, 0 plus 3i, we close x plus C3e to the power 0 minus 3i x. Then expanding this one out, I think we all remember Euler's equation. Euler's equation. Yeah. So by use of Euler's equation, you should be able to arrive at this notation. The C1 plus C2e to the power 0x cos 3x plus C3e raised to the power 0x sine 3x. So then the x is being multiplied by 0 here, and the x is being multiplied by 0. So it means e is being raised to the power 0. E is raised to the power 0. And we mentioned yesterday that raising e to the power 0 is equal to 1. So This part will give us a 1, and this will give us a 1. So the final expression for the general solution now becomes C1 plus C2 cos 3x plus C3 sine 3x. Okay, this is where we ended. So this morning, we'll start the 7th question. Yeah, the 7th question. Question number 7. Determine the particular solution of 2 multiplied by the second differential coefficient of y with respect to x plus 5 dy over dx minus 3y equals 0. Given that dy over dx is equal to 9 when x is 0 and y is 4. Yeah, these are very, very important equations. These where you are given some working conditions. Okay, so let's look at the solution. We convert to the d notation. It will become 2d squared plus 5d minus 3 in brackets y is equal to 0. That's the correct notation using the d operator. Then that yields an auxiliary equation 2m squared plus 5m minus 3 equals 0. Factorizing that auxiliary equation, which is quadratic in nature, we'll get the roots m1 equals half and m2 equals, how do I forget to put an equal sign again? All right, it's supposed to be an equal sign there. So m2 equals negative 3. Those are the roots. Then we now come to the general solution. The general solution is y equals c1 e half x plus c2 e negative 3x. So this is a general solution considering the nature of the roots that we've got. So we can all see that the roots that we've got, the m1 and the m2, are real. At the same time, they are different. They are real, but different. So we use the formula for calculating or for determining the general solution for a case where you have characteristic roots that are real and unequal or different. So this is the formula. GS, which is the general solution, full colon y equals c1 e raised to the power half x, which is one of the roots there, plus c2 e raised to the power negative 3x. So this would have been the solution had we been asked to calculate the general solution. This was going to be the final answer. We're going to end here. But then the question further goes to giving us conditions. Yeah, we are given these side conditions. And the question also says particular solution. So the particular solution is not supposed to have C1 and C2. So in other words, whatever we're going to do, we have to ensure that at the end of it all, we should have the values of C1 and C2 and put them in this general solution, and we'll be done. That will be our particular solution. So let's move. Where do we go from here? So we are trying to remind ourselves to say, since we are given dy over dx to be equal to 9, and when x is 0 and y is 4, then we'll have to differentiate, because what we've been given what we've calculated here, the general solution, it's equated to y. So we have y equals c1 e raised to the power half x plus c2 e raised to the power negative 3x. Okay, this is equal to y. So let's move and yeah, we look at this other stage. We differentiate the general solution with respect to x. Differentiate the general solution with respect to x. That's the next step here. So this is the differential coefficient of the general solution with respect to x. So if you differentiate the general solution, let me put it here so that you'll be able to see it. Let me see if we can have it. Okay. Let's have it on the next slide. On the next slide. Is it here? Here. If we can have it pasted somewhere. Okay. Okay. So that we're able to see it. No, not this. I've moved the wrong. I've moved something wrong here. Where is the general solution? Didn't I copy it? Okay. Copy. Copy and paste it here. Yeah, so this is the one, the general solution, not what we are looking at there. Okay, so this is our general but then the display has to be okay. Animation custom. Okay, then this should be on top. Okay, all right. Okay, so we are fine now. We are safe. I was just trying to put the general solution on top. Trying to put the general solution on top. So this is the general solution, y equals c1 e raised to the power half x plus c2 e raised to the power negative 3x. So following those conditions, it implies that we need to differentiate the general solution with respect to x. Because here we are given dy over dx as being equal to 9. So we differentiate now the general solution with respect to x. So dy over dx, the differentiating half x will remain with half. So that half multiplies with everything. So this is how come we have a half here. Then c1 e to the power half x minus, there is a minus 3c2 e to the power negative 3x, because when you differentiate negative 3x, you remain with negative 3. So multiply everything by negative 3 and it will give you this. So this becomes the differential coefficient. So this is the one that is being equated to 9. This expression after, okay. So I think in 10 minutes time, we should be able to generate a new invite link. They are just warning us. So let me just wind this one in the next 5 minutes. So differentiating with respect to x, we've explained it. Then dy over dx at the point when x is equal to 0, this is how you state it. When x is equal to 0, in this same equation where there's x, we put 0. 0 there, 0 there. It means the e will be raised to the power 0, and the e here will be raised to the power 0. So if these powers are all equated to 0, then we'll have e raised to the power 0 and the e raised to the power 0. And e to the power 0, we stated it, e to the power 0 is equal to 1. So this will come out as a 1, then this will also be a 1. So in the end, we'll have dy over dx. When x is 0, it will give us this expression, half c1 minus 3c2. Then this half c1 minus 3c2 is dy over dx. But up here, they are telling us to say dy over dx is equal to 9. So we equate this expression to 9. So this is the half c1 minus 3c2 is equal to 9. So now, when x is equal to 0 and y is equal to 4 in the general solution, you've seen this general solution? So when x is equal to 0 and y is equal to 4, then the general solution will result in c1 plus c2 is equal to 4. Because the x will be 0, so this will just be c1. Here, the x will be 0, and this will also just be c2. So it will be 4, which is y is equal to 4. 4 equals c1 plus c2. So we're going to have two equations. This will be equation 1, and this will be equation number 2. Equation 1 and equation number 2. And the two equations have similar unknowns. Both have C1 and C2 as unknowns. So how do we solve the two? We solve the two equations simultaneously. We cannot start talking about a simultaneous solution of equations. We expect that I'm sure everyone is able to do this. Yeah, or we consult some grade 9s if we've forgotten. Yeah, so we have two equations which have to be solved simultaneously. And if you do it correctly, we expect that your values will be, the value of your unknowns will be 6 and -2. How you label them, it doesn't matter. It doesn't matter as long as they are different. So here we are calling them C1 is equal to 6 and C2 is equal to -2. So this is not the final answer. We still need to generate our particular solution. So for the particular solution now, we get back to our general solution, this general solution, and plug in the values of C1 and C2. So we now know what C1 is and we know what C2 is. So we'll simply put them in the general solution, and this becomes our particular solution. And the question is done. Very simple, very, very simple. Just following step by step. Okay. Let us move. Oh, sorry, we were warned, so I'll need to end the session, the first half of the session here. Yeah, we'll end the first half of the session here, then continue after some five minutes.